Hello, welcome back to Statistics and Mathematics YouTube channel. Please, today we are going to solve questions on binomial distribution as I promised you. Please, if you haven't subscribed to Statistics and Mathematics Tutor channel on YouTube, kindly subscribe, like and share so that this video will get to your friends for them to also benefit. If you have any question, please don't forget to leave it at the comment section below for me to watch it and then give you good response. Okay, so let's dive into the video. Our first question says that if y has the binomial distribution with parameter n is equal to 10 and our p is equal to 0.55, the first question says that calculate the probability that our y is equal to 7. To find the probability that y is less than or equal to 2 and probability that y is greater than 4. Okay, yes. So here we could see clearly that our n was given to us, right? We had our n to be equal to 10 and our p was given as what? 0.55. Okay, so this is the summary of what the parameters being given to us. Okay, and then we have to state our PMF, and then we know that the PMF probability that our y is equal to r is equal to what? N combination r, okay, times p raised to the power r times 1 minus p raised to the power n minus r. So this is what we have for our PMF. Okay, so here already we have our n and then we have our r, we have our n and then we have our p. So you are just going to substitute them here, right, to resemble this, right? So right now we're going to solve the question. The first question says we should find the probability that our y is equal to 7. So here anywhere you see r, we are going to just put 7 into this one. Once you put 7 inside, this is what you are going to get. That is 10 combination 7 times 0.55 raised to the power 7 times 0.45 raised to the power 3. And then we are going to get our final answer to be what? 0.1668. Okay? And then the second question says you find the probability that our y is less than or equal to 2. That means that we're going to get our y is less than or equal to 2 will be equal to probability that our y is equal to 0 plus probability that our y is equal to 1 plus probability that our y is equal to 2, because the observation is starting from 0, 1, and then it's going to end at what? 2. Okay? Yes. So the first observation, probability that our y is equal to 0, we are going to get 10 combination 0. Okay, the only thing that is changing from this PMF is what? The r, because we have been given different r values. So here we are going to get 10 combination 0 times 0.55 raised to the power 0 times 0.45 raised to the power 10, of which you are going to get this to be 0.0003405, right? For the first observation for y is equal to 0, and then y is equal to 1, I'm going to get 10 combination 1 times 0.55 raised to the power 1 times 0.45 raised to the power 9, and I'm going to get we are getting 0.004161. Okay, and then probably that y is equal to 2 will be equal to 10 combination 2 times 0.55 raised to the power 2 times 0.45 raised to the power 8. And they are getting here to be 0.022886. So for probability that our y is less than 2, we are getting the summation of probability that our y is equal to 0 plus probability that our y is equal to 1 plus probability that our y is equal to 2. And when you sum it, you are getting our approximate value to be 0.0274. Okay, yes, that is the solution to that. And then for the third question, say probability that y is greater than 4. And you know that for probability that y is greater than 4, we can just write it in the form of 1 minus probability that y is less than or equal to what? 4. Okay, and then our y is less than or equal to 4 will be given as what? 0.2615, right? And then we are just going to replace this one here, right, to get 1 minus 0.2615 to get 0.7385. The reason why we got 0.2615 was probability that our y is less than or equal to 4 will be equal to probability that y is equal to 0 plus probability that y is equal to 1 plus probability that our y is equal to 2 plus probability that y is equal to 3 plus probability that y is equal to what? 4. Right? This is what we are going to get. So when we add everything, already we have probability that y is equal to 0, probability that y is equal to 1, probability that y is equal to 2. So you have to calculate for probability that y is equal to 3, probability that y is equal to 4, and then just add them together. Once you add them together, you are going to get 0.2615. Okay, 0.2615. That is what you are going to get here. and then just subtract it from 1, you are getting our final answer to be 0.7385. Okay, that is that for that question. So for question 2, we are saying that let x, comma y, and z be independent binomial random variable with parameter n1, p, n2, p, and n3, p respectively. Okay, so right now the parameters for three different random variables has been given to us. So the x is for n1 and p, and then y is what, n2 and p, and the z is what, n3 and p. And it says you find the moment generating function of y, which is equal to x1 plus x2 plus x3. Okay, so for this one, we know that since these are independent, the moment generation function for y, okay, the moment generation function for y will be equal to moment generating function of what, x, times moment generating function of y times moment generating function of what, z. So right now you have to get the moment generating function for x, right? Yes. So the moment generating function for x, right, will be equal to what? We already know our p here, right? And here is what, n1. So we are going to get p e raised to the power t plus q all raised to the power n1. Instead of n, we are going to use n1 because here we are having n1 to be our n. Okay, and the moment generating function for y will be what? P e raised to the power t plus q all raised to the power n2. Well, here we are having our p, which did not change, and here we have here to be n2. That's the reason why here we are having n2. And the moment generating function for z will be equal to what? P e raised to the power t plus q all raised to the power what? N3, because of what, this. Okay, so all that you have to do is to just multiply them together. Okay, so here when you multiply them, I think I have the solution here, right? So this is what we have, as we have generated it one by one. Okay, so since they are independent, we are going to multiply, and then here once you multiply them together, okay, when we multiply them together, we are going to get q plus p raised to the power t. Since the bases are equal, we are just going to add the exponent, of which we are going to get q plus p raised to the power t, bracket close, n1 plus n2 plus n3. Okay, this is what we are going to get for the a. And the second one says you should calculate for the characteristics function. Okay, and then all that I told you is that once you have a moment generating function, for you to get the characteristics function, anywhere you see t, right, in the moment generating function, just introduce I. Okay, once you introduce I here, once you just introduce I here, okay, we have gotten a characteristics function. So that is what we have done here to get what, our characteristics function. Just introduce I, or else you have to go through all that we have done. So the characteristics function for x will be what? P e raised to the power it plus q all raised to the power n1. Characteristics function for y will be equal to p e raised to the power it plus what? Q all raised to the power n2. For z will be p e raised to the power it plus what? Q all raised to the power what? N3. And you just multiply it, and you are going to get what we have gotten here. Okay, so that is that for the characteristics function. And then we have been asked here to describe the distribution of what? W, right? The distribution of W is the moment generating function of what? The distribution of is the moment generating function of what? The binomial what? Distribution with parameters, right? Where our n is equal to n1 plus n2 plus n3, and then our probability will be what? P. Okay, so here we are trying to say that the moment generating function for the binomial distribution follows what? A binomial distribution with our n to be what? N1 plus n2 plus n3 with what? Our probability of success, that is what? P. Okay, that is the solution for that question. So for question 3, here we are saying that the random variable x has a moment generating function. There is a moment generating function. It said, what is the distribution of what? X. So you want us to describe this moment generating function. Okay, and then we have to note that for this one, this can be written as what? 2 raised to the power 2 plus 3 e raised to the power t, or divided by what? 5 raised to the power 6. This can be written to us as this, and then this can further be written as what? 2 divided by 5 plus 3 divided by 5 e raised to the power t, or raised to the power 6. So this is basically representing the moment generating function for the binomial distribution, okay? And then we know that for this one we can compare it to get our p and then q. So here we have here to be q plus p e raised to the power t or raised to the power 6 n. Okay, so here our q is equal to 2 divided by 5, our p is equal to 3 over 5, and our n is equal to what? 6, right? So here we have described this to be that it our x follows a binomial distribution with our n to be what? 6, and our p, which is equal to what? 3 over what? 5. That is the solution to the first question, okay? And then the second one is telling us to calculate the probability that our x is greater than or equal to what? 1. So calculating the probability that our x is greater than or equal to 1 can be written as 1 minus probability that our x is equal to 0. Okay, so you have to calculate for probability that our x is equal to 0, and then just come and subtract it from 1 to get the solution for that. So here, this is how it can be expressed, because already we know that we know our n. Okay, we know that our n is equal to 6 and our p is equal to 3 over 5. Okay, so here we are going to get 6 combination what? R times 3 over 5 raised to the power r times 2 over 5 raised to the power 6 minus r. And already we know our r is equal to 0. So that is what we have here. And we are getting our final answer to be what? 64 divided by 15,625. Okay, so that is what we have here. We are just going to subtract it from 1, and then we are getting our final answer to be 0.9959. Okay, and then that is question 3. So this is question 4. It says a quality control officer randomly picked a sample of 15 bulbs from a very large that of bulbs known to contain 10% defective bulbs. Find the probability that at least one bulb is what? Defective. So when you are saying at least one bulb, it means that we are going to calculate probability that our x is greater than or equal to 1. So always when we see, let's say something like at least a, it means that a is part, it will be greater than that probability that our x is greater than or equal to what? A. So anytime we see at least is what? Greater than or equal to what? That number. Okay, so here is what? At least one bulb defective, mean that we are going to get this what? Expression as it has been what? Expressed in the slides. And already we know that our p, we have to deduce our p from the question and our n before we start even solving. Okay, so we are saying that our n is equal to 15 because we are having 15 bulbs here, and then our p, that probability of success will be what? 10%. That is 0.1. Okay, so already we have been able to deduce our n and our p. So here when we come here, we are going to get at least one defective to be probability that our x is greater than or equal to 1, which can be further be expressed as 1 minus probability that our x is equal to 0. Okay, and then this is what we are going to get. Once we get the probability, we just subtract it from 1, and we are getting our final answer to be 0.7941. Okay, and the last question says not more than 3 defective bulbs. So not more than 3, it means that we are going to get probability that our x is less than or equal to 3, which can be expressed as probability that our x is equal to 0 probability plus probability that our x is equal to 1 plus probability that our x is equal to 2 plus probability that our x is equal to what? 3, right? So you are going to calculate this one by one. Okay, probability that our x is equal to 0, calculate for probability that x is equal to 1, probability that x is equal to 2, probability that x is equal to 3, and then just add them together. We are getting 0.944 to be that. So kindly do that for me, okay, using the formula. And then question 5 says a random variable y has a characteristic function. This is a characteristic function for the random variable y, and then we have been asked to describe the distribution of y. Okay, and then we know that this can be what? Written as e raised to the power it all divided by plus 4 all divided by what? 5 all raised to the power 7. Okay, and then this can be further be written as e raised to the power it divided by what? 5 plus 4 divided by what? 5 all raised to the power 7. And this we can compare it to what? P e raised to the power it plus q raised to the power what? N. And we can see clearly that our p is equal to what? 1 over 5, our q is equal to 4 over 5, and then our n is equal to 7. Okay, so here this is what? the moment generating function for a binomial distribution. Okay, so we are going to get our n to be 7 and our probability of success to be 1/5. That is the description for that. And then once you have been able to get this one, solving this one will be very simple, right? So we have been asked to find the probability that y is equal to 2. So this is what we are going to get, and our final answer will be 0.2753. Okay, and then probably that y is greater or equal to 1. So for that one too, we are also going to get 0.7903, right? Yes. So I'm going to leave this question for you guys to solve. So please kindly solve and then share your solution at the comment section below. So once you get it right, I'll give you the thumbs up. Okay, this is Statistics and Mathematics YouTube channel. Kindly subscribe, like and share, and then don't forget to click on the notification bell. Bye, have a lovely day.